All right, create a polynomial p with the given information. So it says the zeros of p are, okay, so remember it's always x minus your 0. So x minus your 0. So if my zeros are positive 2 and negative 2, positive 1 and negative 1, that'll be x minus 2, x plus 2, because x minus negative 2 is plus 2, x minus 1, x plus 1. Now, the leading term, 117x to the fourth, x times x times x times x, that's x to the fourth. So if I had 117 out here, I would multiply that, and then we get it. So it says the zeros of p and c equal 1 and 3. So x minus 1 and x minus 3. C equals 3 is a 0 of multiplicity 2. Okay, so there's my 2. Now my leading term, p of x, is negative 5x to the third. Okay, so far that's x. That's 2 of them since it's squared. So that's x to the third. So if I had a negative 5 in front, that should make it minus x to the third. The solutions, or the zeros, are going to be, so I have x minus 0, which is just x, and then x plus 3, x minus 3, and x minus 6. So it's always x minus your 0. And then the next leading term is 7x to the fourth. Okay, so this, let me just simplify that. So if it says 7x to the fourth, x times x times x times x, that's x to the fourth. So I can put a 7 in front. And now it says, here's an interesting one, the point negative 3, 0 is a local minimum, right? Well, that's a 0, right? Because that's negative 3, 0, that's here. That's referencing this 0. Well, for it to be a local minimum, that means that it has to do that. So I know it's going to bounce. And so that's going to have to be squared, because it's going to have to bounce. There's no other way to mark it for that. But if I were to do that, because right now 7x to the fourth, that means they're both going up. Okay, so it's going to come and bounce, cross, cross. Ooh. Cross. Right? That's what it's saying right now. Oh, it says the solutions to your function equaling 0. So this doesn't exist. That's the issue. So there's no 0 here. Okay. Nope, that makes sense. So your answer is x plus 3 squared times x minus 3 times x minus 7. I read that wrong. It's asking for the 0 itself. Okay, so again, asking for the zeros, we have x positive 3, negative 3, negative 2, and negative 4. The leading term is negative x to the fifth. And then this one, point negative 2, which is here, that's a local maximum. And so that needs to be negative. There we go. So state if the following binomial are factors of the polynomial. So remember, there's the key thing here. For it to be a factor, the remainder has to be 0. Okay, your remainder needs to be 0. So you divide it. 1, negative 1, negative 1, negative 2. And we want to know, is my remainder 0? Bring it down, multiply, add, multiply, add, multiply, add. So yes. On this next one, negative 8. So 1, 9, 14, 59. There's no placeholders. add straight down, multiply, add straight down, multiply, add straight down, multiply, 6 times 8 is 48, add straight down, multiply, doesn't look like it. I have remainder -7. So nope, it is not a factor.